When we look at our triangle congruence, we can actually do one in the coordinate plane, so on our graph, and that's side, side, side. When we do that with side, 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 we are using our distance formula. So remember that the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. We're just going to do that a couple of times for each triangle to see if they match up. So with our first example, we are going to treat each triangle totally separate. And they told us that we're trying to figure out if triangle PQR and triangle XYZ are congruent. When we do that, we need to take it one side at a time. So we're finding it for PQ, for QR, and for PR. Looking at that for PQ, writing out our distance formula, is going to be the square root of 5 plus 3 squared plus negative 4 minus 7 squared. When we simplify that down, we get the square root of 185. For side QR, we're going to do the same thing, that distance formula, and we're going to have the square root of negative 3 minus 0 squared plus 7 minus 2 squared. And when we simplify that out, we get the square root of 34. Last side for this triangle is PR, so we're using those points. We have the square root of 5 minus 0 squared plus negative 4 minus 2 squared. And when we simplify that, we get the square root of 61. So that was for our first triangle, triangle PQR. We're going to do the same exact process for our other triangle. So we're using those ordered pairs this time, and we're going to write out our distance formula. So the square root of negative 2 minus 9 squared plus negative 1 minus 7 squared. And we're going to simplify that down to the square root of 185. The next one is YZ. So we're going to write that out with our distance formula, 9 minus 3 squared plus 7 minus 2 squared. We're going to take the square root of that, and we're going to find that that's the square root of 61. Last but not least, we are doing XZ. So we're going to do the square root of negative 2 minus 3 squared plus negative 1 minus 2 squared. We are going to find that that simplifies down to the square root of 34. Once we have all of the distances for each of our triangle sides, we can see if it matches up. So is there a match from triangle PQR and triangle XYZ that we can say is congruent? If we look, there's each side has a square root of 185. Each side has the square root of 34, and each side has the square root of 61. So when we write out our statement, we can say that since PQ is congruent to YX, again, they're both a square root of 185. Since QR is congruent to XZ, and they're the square root of 34. And since PR is congruent to YZ, the square root of 61, we can say that our two triangles are congruent by side, side, side. The only thing is we had to do a little bit of rearranging with our second triangle to line up our points. So again, when we write it, we need to make sure that our vertices stay with each other to make the same congruent triangles. Our second example that we're going to look at, again, we're doing that same exact process to find our side lengths. So we're going to write the distance formula, and then we are going to simplify. So I'm just going to show you that. For PQ, it simplifies down to the square root of 221. For QR, it simplifies down to the square root of 232. And for PR, it simplifies down to the square root of 41. On the other side, we're doing the same thing using that distance formula and writing it out. And we have XY simplifies to the square root of 221. YZ, when we simplify it out, it becomes square root of 82. And then XZ becomes square root of 101. Once we have all of those distances, we can compare our triangles and see if we can match anything up. It looks like we do have one of each side being the square root of 221, but if you notice, our other two sides of our triangles don't match up. There's no pair for QR or for PR with our other triangle. So, since our three sides are not congruent, we say that this triangle is not congruent because we do not have side, side, side. We don't have three pairs of congruent sides. So looking at side, side, side in the coordinate plane is all using that distance formula. If we remember that distance formula, we are set.